So we're looking at a early 70s, maybe like a 72 R5 350 cylinder. These specifically need, in my experience, a little bit more love than the rest. The later 350s, the reed valve ones, they get a little better. The 400s are pretty good. The issue with these in stock form is the mismatch between that cylinder liner and the aluminum tunnel. This one's been fixed. Did the port work on it? In stock form, as I received this, that sleeve was quite a bit lower down than the tunnel, and there was a significant step. So it reduced the duration of the transfer ports, and it introduced a whole bunch of turbulence right there at the top of the transfer port, where you really can't have turbulence. These had a huge step right there. And both cylinders, same problem. Both sides, left to right, same issue. Had to fix this over here, required the same stuff. And they both had a huge step right there. And it's tough with these, considering the bore diameter. They're kind of small bore cylinders. What I ended up using for this was the ordinary hardware store variety, the Dremel right angle tool. You can see I've kind of crudely hacked it off and shortened the collet, shortened the whole thing. I shortened it up everywhere I could. And then I used a carbide bit, such as this one here. Carbide's tough to work with. It's really hard. Can't really cut it, but you can break it. So of course these bits were too long, so what you have to do is set them on the edge of something like that. Or if you got something, whatever that'll hold it, then you kind of smack it where it's not supported, and they fracture, and you can shorten them in that way. This one here, I think, is too long still. I had to knock it down. I don't know where the other one is in my pile of shit up here. But that's what you got to do. You can get yourself one of these here at any hardware store. I mean, it's just a regular off-the-shelf Dremel. So these aren't high-quality porting tools, but this particular one has gotten through several cylinder port jobs. Not just these two R5 cylinders. The SC500 cylinder and that one back there, that one's been done. In there, in the other garage portion, I got a couple of DT360 cylinders I ported. This gets the job done. The thing with those, like the SC500, that's a 95 millimeter bore. The DT is an 80 millimeter, so you can use one of these out of the box. No modifications necessary. For little RDs, these are 66 millimeter bores, so it's tight, especially once you have the cutting bit on there. You can get it in there though. This doesn't have any none of that stuff. So this is just the adapter with the shortened, that threaded portion. But this will get in there, especially with the bit, and then you can do your blending, your smoothing. What you have to be careful with these transfer ports, the most important thing is the aim. So there's two different areas you have to worry about. There's the leading edge, which is kind of right there between the exhaust port. That little part right there directs the most important part of that transfer flow. So if your leading edge is out of whack, you're going to have a piss poor scavenging, which is kind of how they are stock, In this case, on this leading edge back here, I had a mismatch just like I had on the port roof. There's a mismatch between the sleeve and the cylinder at the leading edge as well. So that's going to create turbulence right here. And it's going to cause a lot of that. Instead of it being directed in like a smooth jet, you could have like laminar flow through there, I think is what they call that. If you got turbulence, it's going to be doing this shit. And a lot of that's just going to be going right out the exhaust. And up here on the port roof, if you have turbulence there, of course, instead of a nice smooth jet, it's supposed to transfer into the cylinder in an orderly fashion. It's supposed to converge near the rear cylinder wall and fill up and over and scavenge out. If you got a lip here at the top, it's going to cause eddy currents to form. It's going to cause mixing of the transfer stream. With the fresh transfer mix coming in and the burned exhaust, you're going to have a lot of intermingling. I'm not sure why they sold these the way they did, because in stock form they are so bad. I've never seen anything that poorly done from any manufacturer. Yamaha especially, it's like, what the, I expect better. Even these are old tech. This is like 70s. Even in the 70s, though, they knew better. That was just, it's almost like they were worried about people getting hurt. Maybe these bikes, they thought they were too fast. I don't know. They handicapped the fuck out of them, though. So yeah, that's the best thing for these R5s. You can fix up the main transfers. You get the biggest benefit from cleaning these up. Raise them up just enough to meet the transfer and fix this junction. You raise them up too much and you're going to increase the port timing to the point where it's going to affect low end. It's not going to be as responsive. If you're racing, you want to rev this thing to 10 or 11,000 RPM, yeah, go ahead and raise them up. You're going to need some more transfer duration. But for a stock engine, these are pretty nice stock, like pleasant, well-mannered. I left the exhaust port alone. I do need to blend that. Same thing, sleeve doesn't match the cylinder. Easy fix. That's the exhaust ports aren't hard to get to on these. It's those transfers. You gotta get creative with the right angle tool when you gotta modify it. Intake side, same kind of problem. You gotta in this one there was a pretty good size lip right there at the top. Right there. Again, the sleeve protruded down into the port, caused turbulence. It wouldn't be a bad idea to take care of that little lip too. The carburetor spigot to the cylinder. There's a little bit of a mismatch there. You just don't have turbulence. And these things in stock form, oh my God, I don't know. Again, they must have been afraid that these were going to be such a hot rod. People are going to be getting killed left and right. Maybe they were worried the drum brakes weren't going to be sufficient. I don't know. They sold these in a really poor state of tune. Oh yeah, I got actually a little bit of work to do down there. You probably can't see it in the video, but smooth. Everything's got to be smooth. And in this this transfer, I got a little bit of jagged. It's just not nice, and I got to get in here and clean that up a little bit. Just right there. Can't really see it in the video, but you have a nice smooth radius. Everything's got to be smooth. You don't have any sudden edges, any changes in cross section. This one's still got a little bit of a lip right there. I got some more work to do, which is amazing because these cylinders ran so good, and there's still more in there. So I'm kind of excited to get these finished up. Now that I know how good they can run, I'm definitely interested in exploring the R5. Stock, I just kind of threw these in. It was like, wow, those ports look like shit, but we'll see how they do. And they didn't do very well. The bike ran poorly. The throttle response was weird. From closed to about a quarter throttle, it made noise, but it didn't really do anything. There was no response. It didn't, the transfer streams were still kind of weak at those low throttle openings. When you open those throttles up a little further, it would start to pull a little better, but the power band was brief. The low end wasn't great. Mid-range was iffy. And the top end wasn't, they didn't make much power anywhere. But what little power they did make was kind of focused on the mid-range. If you look at the port timing, that's odd, because these are pretty conservative as far as the exhaust port height. These are the lowest port height 350 cylinders you can get. I think they're 38 millimeters from the deck. So that means you got more trap volume, and you got, more punch for the displacement. The 350 revalve motor, they put quite a bit more timing in those. These weren't 38. No, that was the Daytona 400. These were 30-something. 32? I don't know. I know the later RD350, they raised these ports up to like 29.5. And, if you're looking for top end, that's how you get it. But the problem is every time you raise the ports, you're raising the power. The torque curve moves up. You're trading off bottom end. You're going to make more top end. But these R5s are kind of interesting because they are a plain piston port cylinder. You see there's no obstructions in the intake tract. It's carburetor, right into the cylinder, right into the crankcase. So these things offer minimal pressure drop. The reeds present an obstruction. They're a restriction. These R5s, you got no reeds. You just got a throttle slide. Once your throttle slide's open, there's nothing in the way of filling that crankcase. So these things actually offer, and I've read about it, some of the old guys will tell you if you do some reading, those R5s, if you tune them up, you're not going to have as much torque, maybe, as a RD350 or 400. Once you tune it, it becomes more of a on and off kind of power band. In stock form, though, you don't lower that intake floor, and you don't raise that exhaust port roof. The intake floor is a port timing factor in these piston port motors. So depending on your combination, if you keep your porting conservative on the intake and exhaust, you're going to find this is actually a really nice, torquey, broad spread of power. Dare I say even broader than the 400 motor I have in this thing now. That thing probably do some porting. Probably something like this. What I had to do on the R5 is raise those A transfers. That's the big one. I had to raise those up a little bit and they open before the B transfers. And I'd like to do some work on those too. There's a little bit of a mismatch, but the vast majority of the flow through the transfers is through the A transfers. So I'll raise those up, and they open first, and the crankcase effectively blows down through those. And the B transfers open later with lower pressure, and they flow less of the total volume. And the way this seems to work in the R5 with this ported the way it is, it works better. The RD400, RD350, they open the A, B, and the boost port all at the same time. And the issue is with, in my opinion, my assessment of the port layout, the A transfers are more conventional, horizontal or close to it. They enter in a kind of a flat, they don't aim upward, they just flat right across the piston crown. The B transfers, kind of like these R5s, are aimed upward. So the problem, in my assessment, the way I understand it, when these all open, you have a lot of velocity going up the back of the cylinder. The A transfers are coming in from each side, pointing towards the back of the cylinder. The B transfers are aimed inward and upward, and then the boost port is just angled upward at like a 45 degree. So the problem is these two B transfers, they're opening upward, and there's nothing to counteract their velocity. So the A and the two A transfers on each side, they're aimed backward, they converge, they hit the rear cylinder wall, and they kind of lose their energy. There's nothing to really slow down these B transfers as they aim upward in conjunction with that boost port. And what that seems to do with these RD 350s and 400s is it makes great top end power, but it's not efficient at low RPMs because a lot of that velocity, when those B transfer ports and the boost port open, they all open at the same time. That wants to go up the cylinder wall, hit the head, it makes a loop around, and a lot of that's getting lost. That velocity just carries right through the exhaust port. A more modern porting layout, I don't have one here on the bench in front of me. Probably got some in the other room. Kind of a universal porting layout that you see on more modern two-strokes. You always have something to counteract the velocity. So this guy here is a good example. This is a DT360 cylinder. You can kind of see there A transfers, B transfers, and the boost port. The A and the B enter horizontally. A transfer is aimed across. That guy on the left is aimed to kind of counteract this guy over here. So what happens is that A transfer stream is aimed at this B transfer stream. They collide and they lose a lot of their velocity. So what you have is the A transfers are pushing the mixture towards the rear of the cylinder. The B transfers are counteracting some of that velocity. And so what ends up happening if you have an efficient porting layout, a lot of that the energy from the transfer streams is lost, and you have a kind of just a slow filling from the rear towards the top of the cylinder, and it kind of fills from the back to the top to the front, and it kind of just displaces. You don't have a lot of energy. You don't have a shooting stream just blasting into the cylinder because it's going to shoot through. And this is an issue you had with a lot of these older porting layouts. You know, they didn't know how to trap that charge in the cylinder. Once the transfers opened, they tried raising crankcase pressures, they tried lowering transfer ports, they tried all kinds of goofy shit. With the modern stuff, now even this old bighorn cylinder I got here, these actually work pretty well. These don't have hooked transfers, which is what I did on those DT cylinders. But you can see, same kind of thing. We have a flat A transfer, flat B transfer. We have a boost port at the back. This is really good for 1970. Literally, these were introduced in 1970. This is a really good porting layout. They could have done a little bit better with the port areas, you know. Kind of small ports, but, you know, these have huge power potential. These rotary valve 350s, you can get 45, 50 horsepower out of them. Because what they do is they aim the main A transfers back. The B transfers, if you look at them, they enter. You can hardly tell because of how corroded this one is. But they both enter, and they're aimed straight across at each other. So the energy of these two streams, they collide, and they cancel out their energy. And that just kind of, you end up with just you know, the transfer streams collide, and you end up with like a cloud just filling. And that boost port back there, it's a very wide boost port. That guy directs that charge that's accumulating in the back of the cylinder kind of up, kind of wants to bend that up and kind of fill. So it's not as energetic as what you get with these RDs where you have 3 ports. This is an R5, so we don't have the boost port, but the 350 and the 400 have a port in that intake port here. Those are rotary, or not rotary, those are reed valves, so they just have an open port back here. The RDs have so much energy transferring up A lot of that charge is lost. There's nothing to slow it down. So, and that's kind of how they run. The 402, unfortunately, much to my displeasure. It makes good low end, but it could be better. It really gets going around 6,000 RPM, 6 to about 7,500. It's cooking, but it's got kind of a flat mid-range where I feel like the better porting layout, we could trap a little bit more of that transfer volume in there, and you'd have a little wider power band. Of course, this is a more modern, maybe not by current standards. This is a 2003 KX125. Let's compare. So you got your A transfers, your B transfers. What you can really see about these, the B transfers are strongly hooked. So you got the leading edge, the trailing edge, the leading edge, the trailing edge. The trailing edge of these guys, this is a really highly developed cylinder. So leading edge, trailing edge. The B transfer, leading edge, trailing edge. The trailing edge of these B transfers is aimed forward like that. And again, what that does, you got your transfer stream coming through. Like from each side, it's symmetrical, right? So you got this side is coming back. This transfer is aiming back here like this. The B transfer is aimed forward. Basically, you have like a butterfly wing type of pattern. All of these streams collide, lose their energy, and they just kind of fill. You still have the leading edge guiding the, it's kind of like providing a wall of mixture. So it's preventing charge from just going straight to the exhaust. But all this back here, towards the rear of the cylinder, it just fills in here, and all it can do is displace upward. And that's what this guy here does. It kind of helps push that. It kind of rolls it up over the top. So that's a really high performance cylinder. This is a 7 cubic inch, 125 cc motor. These guys make 30 to 35 horsepower at the wheel. So 12,000, 13,000 RPM. And good bottom end too. Of course, the power valve helps, and that big ass bridged exhaust port surely helps. I wish I could have something like that. Yamaha wasn't doing that in the 70s. Even on their TZs, I think they just used a regular large oval exhaust port. Bridges are the way. So if I ever have a sleeve made for one of these, I'm going to bridge it for sure. But anyway, as far as getting these to work better, first thing, fix that step, because these R5s were so bad from the factory. Again, you're going to be surprised the difference it makes. If you fix that, you just got to do all four. Make sure you don't screw it up. If you're not feeling great about that, send them out to a professional, because there's guys that do this for a living. You don't have to do it all yourself. And it's way better if someone else screws it up and they have to fix it. You screw it up, you got to buy new cylinders. So anyway, if you got an R5, definitely recommend it. This is a must do. If you have an RD350, RD400, still worth looking at, because the casting on those was better, but they're still not perfect. So if you have any mismatch or any kind of casting slag or any kind of junk in there, clean it up. Can't have turbulence right there. You can have turbulence other places where it's not good, but it's not going to be a deal breaker. You got turbulence right here where the transfers are emerging from the cylinder wall. It's going to destroy, efficiency. That means fuel economy. That means power output. Your rideability. The difference this made on the R5 from before and after was a night and day difference. On a modern cylinder like this, you get imported, and it might really not be that much different. You might get maybe if you measure it on the dyno, you might get a little bit. But these things here, the vintage jobs, man, huge difference with proper porting. So it's a must-do with the R5, and I highly recommend it, even if you have an RD400, RD350. Just take a look and see what can be done, because if you have a little bit of a mismatch, and that's not uncommon. I think my 400 here, I had to clean up the port roof a little bit because the sleeve was actually higher, closer to top dead center than the tunnel in the cylinder. So just you got to kind of blueprint them and make sure everything is jiving, and make sure it doesn't have to be a specific 121.5 degrees of duration. Just make sure that you don't have huge steps or lips or ragged edges in there. And man, these run so much better. The R5 magazine tests of the period, I think if those are any indication, they were all fucked up from the factory. They got like 33 miles per gallon. This one here, I've gotten over 50. Performance-wise, I'd put it maybe even slightly ahead of an RD350, because it's got more meat in the mid-range. You don't have to rev it all the way to the moon to get power. These R5s with a conservative intake and exhaust port timing, they make good power from a low RPM, and they sign off around 7. They rev to 8, but there's not as much power up there as the RD350. But honestly, for a street bike, the R5s are a really good choice. So underrated for sure. They're flawed, but you can fix them. Some basic tools. Be very careful. You can ruin these things. Oh my God, don't just go in there and start butchering away. One thing you want to make sure is have both of these ports left to right. Make sure when you're done porting they open at the same time. Make sure your aim is good. What I'm talking about by when I say your aim is good, they have to have a rearward bias, right? And you can kind of follow the cylinder wall and you can see what the factory was intending. Get my flashlight out. You can see the angle of that cylinder wall. It starts down here. It's basically that same angle. If you follow that as it opens into the cylinder, they want to see it aimed more or less like that. So if you have one that's like this, the other one's like this, it's going to be a problem. So make sure your entry angles, and you can kind of eyeball them. Just look at it from the top. I don't always get it right, but you know, I try. You look at it from the top and you can kind of see roughly that this one is aimed at about the center of this cylinder head bolt hole. And the same thing should be this side. You look at it, you can kind of see where the shadow casts. You can kind of see this one's roughly aimed at the same place. So that's important. The vertical, horizontal angle, and then the get rid of those ragged steps and the edges. And now you can kind of see in that one, you get a little step there. There's probably a step on the leading edge, but the A transfers do about 80% of the work. The B transfers, you don't really want that much flow through them anyway, because again, they're kind of pointed upward, and that's definitely fucked up. So anyway, if you got an R5, check that out and give it a shot, or send them out, have them done. If you have them done by a professional, maybe make sure it's somebody that has a reputation and knows what they're doing, and make sure they understand what you're looking for, because you can port these things to make wicked top-end power, and they have nothing until 6,000 RPM. So don't send it off to a guy that's just going to build your drag bike if that's not what you're looking for. That's why I kind of like doing it myself, because I know what I want, and I take my time. I'm not doing this professionally. So when it's right, it's right. I don't have to rush and try to cut corners. So yeah, I hope that helps. And, maybe I'll do another video about this one. I got more jetting progress made on that 400. That's another subject. This one's getting long. So anyway, porting, check it out. These things, a lot of potential left in them. Way more than a modern bike. So it's worth doing for sure. Thanks for watching.